Alright, we're going to continue with Chapter 4, Section 1 on initial conditions and position. When we started doing applications with derivatives, we talked a lot about position, velocity, and acceleration. We said S of t is the position function. And to get velocity, I could just derive or find S prime of t to get velocity. I could derive velocity or find the second derivative of position to get acceleration. We can use our understanding of that relationship and our understanding of integration to work backwards. So if I were to start with A of t, which is still acceleration, I could integrate my acceleration function with respect to t to get my velocity function. I could integrate my velocity function to get my position function. To do the problems today, as well as the problems in your homework, you need to know the acceleration of gravity. That's the starting point of all of these problems. Alright? And now the acceleration depends on the units. So, and these are rough estimates, but for these problems it'll work fine. The acceleration due to gravity is negative 30 feet per second squared. Or in terms of meters, we say that acceleration due to gravity is equal to negative 9.8 meters per second squared. So let's start with a problem where the ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. We want to find the position function and find when the ball hits the ground. When we read word problems, we need to understand that the starting position, or the initial height in this problem, is S of 0. And that the starting velocity, or the initial velocity, is S prime of 0, or V of 0. So for part A, I would start with the acceleration being negative 32 because we're dealing with feet. And from the word problem, I know that V of 0 is equal to 64 and S of 0 is equal to 80. So to find the velocity function, I would integrate negative 32 dt. So reversing the power rule, V of t is equal to negative 32 t plus c. To find the c, I use this piece of information right here. V of 0 is equal to negative 32 times 0 plus c. So c is equal to 64. So now I know my velocity function is equal to negative 32t plus 64. To get my position function, S of t, or the height of the ball, I would integrate negative 32t plus 64 with respect to t, and I would get S of t is equal to negative 16t squared plus 64t plus some c. Again, they tell me that S of 0 is equal to 80. The initial height is 80. So S of 0 is equal to negative 16 times 0 squared plus 64 times 0 plus c. So that c is equal to 80, and my position function s of t is equal to negative 16t squared plus 64t plus 80. For the second part of that question, it says, when does the ball hit the ground? Well, I already know the position, or the height function, is equal to negative 16t squared plus 64t plus 80, and I want to know when this is equal to 0. So all I need to do is solve that equation. I can solve that equation. All I need to do is factor. I'm going to factor out a negative 16, and I'm going to be left with t squared minus 4t minus 5. So negative 16 t minus 5 t plus 1. So the ball hits the ground when t equals 5. Here's a very similar problem I'm going to give you a few minutes to try, but I want you to notice one thing. Here we're not given the initial velocity, we're giving the velocity after 1 second. And we're given the height after 1 second, which means that they're not giving me v of 0 and s of 0, they're giving me v of 1 and s of 1. So when I'm finding those specific constants of integration, you need to be plugging in 1 for t. I'll give you a few minutes to work on this problem. So here's how I arrived at my position function. Just like last time, I took the velocity and I integrated. I used v of 1 being equal to 20 to solve for my c. Then I integrated that velocity function. I used S of 1 being equal to 60 to find that C, and here is my position function. To find when it hits the ground, I would set it equal to 0 and either factor or use the quadratic equation. Use the rest of the class period to complete these problems from Chapter 4, Section 1. Remembering, of course, that you have a quiz tomorrow on integration, including U substitution, and these application problems having to do with position, velocity, and acceleration. The answers to these questions will be on Edmodo this afternoon.